Okay, let's continue. We now move from the module to packaging, and we are very happy to have with us Stephen Tang, who's an R&D engineer at Hangzhou First, world's leading encapsulation producer, and he will talk about packaging solutions for bifacial N-type modules regarding reliability. Stephen, the floor is yours.
Hi, everyone. This is Stephen Tang from Hangzhou First. Today, my presentation is about packaging solution for bifacial N-type module from reliability point of view. As the speaker has stated a lot of benefits of N-type cells, such as high efficiency, lower AID, and high bifacial rate, etc. And more importantly, with the cost down, we have over 10 gigawatt of mass production from this year, and even we have more than 20 gigawatt capacity build from this year. So we call this year 2022 is the first year of N-type. However, I think it makes no sense if the module reliability is poor. So firstly, I want to present the packaging solution for bifacial and TOPcon cells. So what's the difference of TOPcon in terms of reliability? I think there are two major significant issues. One is the corrosion. Due to its unique silver aluminum paste, the finger is easy to be corroded under the damp heat environment, and due to its failed pass-width layers, its TOPcon is prone to PID. So how to solve these problems? One is you can use gas as a recover. Yes, that's the best way, but there's still market limit. You can see from this chart. In 2022, the residential in the commercial market is over 50%. So there is still scenarios that HRBB modules is needed. And using high water barrier backsheet is another option, but unfortunately, there is still some technical difficulty. So challenges and the chances lead to the encapsulated film, since we have a lot of materials. We have EVA, we have POE, and we have EPE, which combines the advantages of both EVA and POE. So what's the result? Unfortunately, it's not that easy. You can see three of these types of films failed the PCT test. And even POE is not 100% safe. Even it has no acid and has known as 3 to 5 grams per square meter per day of WTR. It is still not enough to prevent moisture to diffusing and to the surface of the cells from probably the two passes. One is from the edge of modules, and another one is from the gap between the cells. And the CO2 test paper experiment also verifies our speculations. You can see from this picture, we use the POE as a encapsulant, and we put 3 pieces of test paper on 4 different locations, which are the module edge, the gap between the cells in the middle of the cells. And firstly, the edge one and the gap one is change the color from blue to brown at 24 hours of PCT. And subsequently, the middle one is changes their color at and the 48 hours. So this is fully demonstrated the ways of the passes of the water in grace. So question is how the corrosion could take place. We think this is probably a electrochemical corrosion mode in which the water acts as a reactor medium, and probably the metallic ions in POE act as a kind of a catalyst, which can accelerate the corrosion. So it seems like if we can complex the metallic ions in the POE, then the corrosion could be mitigated. So based on our POE technologies, in this year 2022, we developed a TF4N POE, which has a high ability to anti-finger corrosion, particularly for the G2B modules, and also has a high ability to anti-PID. Yeah, this is a very interesting experiment. Looking at the comparison, POE1 is from market, and you can see it can reach around 70% of FF loss at 144 hours. In contrast, our TF4N can give less than 5% of FF loss. So that is amazing. And for PID, our TF4N also has a good result. We use the TF4N as a front layer, and we use EVA or WEVA as a real encapsulation, and the power loss can be less than 5% in 408 hours. So this two mode is suggested by us for G2B modules. And for G2G modules, I think things going to be easy, since there is almost no way that water can go through the modules. So for the front layer, we can use the POE, we can also use EPE, and for the real one, we can use EVA and also EPE. It's okay. For part two, I want to speak about the high reflectivity black backsheet for the bifacial module. Since the residential market is continuous banning and the appearance is highly required. So why we need HRBB? You can see this picture compared to the aluminum BSF seals. The PERC bifacial seals and the N-type bifacials can transmit the infrared light, particularly for the wavelengths below above 1,000 nanometer, and this part of the light can be reflected by the backsheet, although it looks black for our eyes. So this part of light can be utilized then by the seals. Yeah, you can see this chart compared to the common black BS. The HRBS can reflect as high as 70% of the infrared light, just as the white BS, and it then can give more than 2% of power gain. This is 78 series and TOPcon modules between the HRBB and common BB, and you can see we can give 11 watt more power. This is an outdoor demonstration test in China. Compared with the common black BS, module power gain is about 2.25%. And the energy gain of each series can increase about 3.2%. That is the million. And in part 3, I want to share a little bit about the packaging solution for HAT bifacial modules. As we all know, there are three issues about the HAT modules. One is the UV damage of the amorphous silicon layer. And the second is water permeation with edge. And it then can damage the TCO. And the third one is the delamination between the film and the stairs. For this, we have edge sealant solutions. We use a PIB as a material. It has an excellent barrier to moisture with its dense cross-linking, and also it has an excellent bonding performance with glass. We have for the encapsulant, we have the high peeling strength POE and also EPE. You can see from this picture, compared to the common one, our POE and EPE is much higher in terms of the peeling strength with the HAT cells. And also we have it has a high block of UV up to 308 nanometers. Thanks for your attention.
Thanks, Stephen. Very interesting. Okay.
Thank you.
If there are any questions, please write it in the chat, and it would be nice, Stephen, if you can take a look and answer in case there are any questions.